What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series, we're going to continue converting the 2.5D or 2D fighter to our 3D fighter. So remember, this is a mini-series. My actual fighting game series is still going to remain that 2.5D, however, a lot of you have expressed interest in converting it to a 3D game, so we've begun that process. And so far, we've covered 3D movement and 3D boundaries. In this episode, I want to cover animations on our 3D movement. Really, this is only going to affect the walk animations. And you could probably add something like rolling animations as well, but they'll be handled the same way. Now, we're going to have 2 episodes to this because the method I'm going to be using is split up, and I want to make sure that we're careful and we catch all of the instances of this. So, first of all, you can see that I have walking here for my forward and backward, just like I always have in the series. Additionally, I have animations for walking left and right, and this will, of course, work for the other character as well. So that's what we're going to be covering today. But if you'd like to get caught up in the series before checking out this episode, I'll link you to the first part of converting the fighter from 2.5D and 2D to 3D right here in the top right corner. Alternatively, if you don't care about that and you care about the actual fighting game tutorial itself, then I'll link you to the entire playlist to that series right here in the top right corner. But with that out of the way, let's go ahead and get started. The first thing we have to do after this is make our blend space. Now, to create a blend space, we need to have a set of animations that are going to go into that blend space, and essentially we're going to use 2 parameters, a direction and a speed, to determine what animation is actually going to be played. If we go into where our animations are, go to my mutant, my animations, my converted folder, you'll see that I have 2 new animations today. Mutant walk left, right here. This is walking to the mutant's left. And we also have a mutant walk right. This is walking to the mutant's right. Of course, I also have my actual walking animation that I've used in the series for a very long time, which is my forward and backward because it plays at a negative rate, like this. So those are the 4 walking animations that we need. And we will also be using our idle animation as well, right here. We're going to use all these animations in a blend space to get the result that we want for today's episode. So we need to make a blend space. When you create a blend space, you'll choose between a 1-dimensional and a 2-dimensional blend space. Technically, either will work. So let's add our blend space. We're going to press plus add here, and we want to go to animation and blend space. When you select this, you'll have to pick your skeleton. Just pick the skeleton for your character. For me, that's my mutant T-pose skeleton. At this point, I can go into it, and this is what I should see. I'm going to skip over to my blend space that I've already created and filled out, but you can keep working in this one. So I've called my blend space Mutant Walk BS, stands for Mutant Walk Blend Space. And when we come in here, we have these axis settings section. And we have horizontal axis and vertical axis. For my horizontal axis, I want to use direction. For my vertical axis, I want to use speed. So you can fill out the names here now. Technically, the names don't matter. They're just labels for what the data is representing. You can call them whatever you want. This is what they actually are, so we might as well just stick to that. The minimum axis value is going to be -180 here, and the maximum axis value is going to be 180. So the direction is basically going to be 0 to 360 degrees, and the reason we split it into -180 and 180 is because we are going to call a function in the animation blueprint that returns a value between that range, and we're going to use that to determine what animation we should play. Now, we don't actually need all 360 degrees, we really just need 0 to 270 or -180 to 90. However, for now we'll leave it like this. I'll explain why we don't actually need that full range later. Everything else in this section is fine. Smoothing time is something we will probably use to make things look a little bit nicer, but it's not required we actually do that right now. Vertical axis is speed. The minimum axis value is going to be 0, like we're not moving, and for the maximum axis value is going to be 600. This is not a random value. If you go into your character blueprint that this blend space is based off of. For me, all my characters have the same maximum walk speed, so it doesn't matter. I can go to my base character VP, but if your characters have different walk speed, and ours probably will in the future, you're going to want to go into the specific character blueprint, in this case, my mutant BP. Then I'm going to click on class defaults, go to the search section here, and type max walk speed. This gives you their maximum walk speed. For me, that is 600, so I want to just use this value as my maximum axis value here. Again, everything on this axis can be left alone unless you want to alter it. The rest of the settings are completely up to you. Feel free to change them or not. Doesn't really matter. Depends on your preferences. Now what we need to do is add our animations to this blend space now that we have all the data set up. First things first, we just look at our axes here. So we have direction on the bottom and speed up the top. So since speed is our vertical axis, we have 0 to 600. The bottom animations here are going to be the idle animation. Now, technically you only need one of these. You don't have to do it for every single section. So let's go ahead and add our idle animation at the 0 centimeters per second speed. So mutant idle, you can just drag it in from this list, put it into the graph, and it will place it here. Then you can click on the node and then manually input your direction and speed. So for example, for this bottom left one here, my direction is -180 and my speed would be 0. Let's make it say 30. That way we can visualize it. It's a little bit above the one I already have. And then you can just click on it and delete it or backspace it to get rid of it. You can press Control and move your mouse around to see what the blend space will look at any given point. Your animations will likely flow better than mine because mine are just from Mixamo, but you can see as I move the different directions, the mutant is actually turning those ways. You see I have idle for this one, idle for this one, idle for this one, for this one, and this one. So the speed is 0 every single time, and I'm just going up by 90 degrees each time. So -180, -90, 0, 90, 180. Your blend space may be more complicated than mine, but for me, I just literally had the other set of animations up at the top at 600, and then just played the corresponding walking animation. So for me, direction of -180 is my walk left animation. This is the character walking to the left, their left. This is a direction of -180 and a speed of 600. So I just want to grab my walk left animation, bring it in here, and put it at those values. Now we're going to go by the same rules, so we're going to add 90, which would put us at a direction of -90, and a speed of 600 is going to be walk forward. That makes sense because if walking left was -180, move clockwise 90 degrees, we're going to be at the forward direction. And add 90 degrees again, and we'll be at 0, direction of 0, and that's going to be to the right, walking to the right. So you see a direction of 0, speed of 600. Now if we add 90 degrees again, we're going to be walking backward. So that would be a direction of 90 with a speed of 600. Now I don't actually have a walking backward animation. I was playing the walking forward animation at a rate of -1. You can't actually do that in a blend space. If you try and change the scale of an animation, which is possible, you won't be able to change it to a scale of less than 1. But just imagine he is walking backward here. That's what the mutant would be doing if I had a corresponding animation. So we'll add one. So just know that -180 is left, -90 is forward, 0 is to the right, 90 is backward. Again, we don't really need this 180 spot because if you have a circle at 0 to 360 degrees, if I load up paint here, if I have a circle, we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. See how 0 and 360 are really representing the same point? Technically they're different because 360 degrees means we've already gone around this one time. 0 degrees means we haven't gone around it, but they're at the same point. They're representing the same point on the circle. In this case, -180 and 180 are representing the same point on the circle, so we don't really need to represent them twice. This is why we don't need to go from -180 to 180, but rather -180 to 90. Try and change this, you'll get an error because the one animation that I put in there, the idle in 180, no longer fits in this graph, so we need to change it. You can find all of your animations in this blend sample section. So I can see the name of the animation and then the ID with it. So in this case, I'm going to go through my idle animations and I'm going to find the direction of 180, which is right here, and I don't need this one anymore. And I can change the direction to say 50. I'll see that that is this node right here, and I can go ahead and delete it. So there we go, that's our blend space. Now we just want to play this animation instead of our regular walking animations. So we're going to go to our mutant anim BP, and this is our state machine in here. Our state machine previously had idle as its own animation, and we had walking forward and walking backward as its own animations. You could technically follow this and add a walking left, and walking right, and that would work perfectly fine. If you want to use the blend space, however, we can combine idle, walking forward, and walking backward into one state. I'm going to do this by disconnecting my walking forward and walking backward animations. So I have my idle to walking forward transition rule right here. I've disconnected it temporarily. This will be added back for the fighter. Don't worry, it's nothing you have to do. This is just if you're using the 3D fighter and you want to use that blend space, I'm disconnecting this transition rule. And do the same for idle to walking backward. It's disconnected. Then I've gone into the idle state. I've disconnected my mutant idle animation and instead added my blend space in here, which again I called mutant walk BS. We want to use the output into the result, and we want to pass in a direction and a speed. Now the speed we actually already have by default in our animation blueprint because it comes with the template that we used and we never took it out. So here we can actually use it. There's an animation speed or character speed variable that you should have in your event graph if you go to your blueprint update animation event. So a lot of this is custom behavior, but if you scroll over, there was a section that came from the template, which is right here. So this isn't anything new, but if you removed it, you can feel free to add it again. Basically, it takes the pawn owner, try get pawn owner node, and there's a reroute node here, this blue node that I'm following. It gets the velocity of the pawn owner. The pawn owner is the owner of the animation blueprint, so in other words, our mutant character. It's getting the velocity of that character, getting the vector length of that character, which just basically converts it from a vector to a scalar, get the size of it. This variable right here is what we're using for our speed because that is representing our character's current walk speed. So you can just grab this variable, animation speed, get it, and pass it into the speed. The direction, though, is one we're going to have to create. So let's go back into the event graph and let's make a new variable, plus variable. I called it character direction. It is a float. So you can just select float, call it character direction, default value of 0. Now, we want to use that same node that we were using to get the velocity, but instead get the actor's rotation. Get actor rotation. Now, note that the actor is not rotating when we were moving those directions. However, the character is inputting a direction that would rotate them to that direction if we allowed it. So while we're not rotating it, we can determine the direction that they would be facing by using the direction of the velocity. So we use our get velocity node in our current actor's rotation and call a function calculate direction. Calculate direction. Pass those two in. You can see it popping up in the comment for this. The range of return will be from -180 to 180, useful for feeding directional blend spaces. Perfect, because that's what we're doing. So return this value into set character direction. So grab character direction, set it, pass this into it. At that point, we can go back to our state for our idle and pass in the character direction variable. We will now get the result that we saw earlier. Anyway guys, thank you so much for watching this video on converting your fighter from 2.5D and 2D to 3D. If you enjoyed and you want to see more, please subscribe. Really helps me know what you guys are interested in. Make sure you can keep up with the series, and also it supports me the most out of anything else you can do. If you want to support the channel further and get some benefits along the way, you can check out the Patreon, YouTube membership, and Discord subscriptions like so many kind souls already have. I'm so incredibly grateful. Thank you guys so much for the love. If you ran into any issues while following this tutorial, feel free to join the Discord community. Link in the description, and I'd be happy to help you out. That's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, my friends.